Welcome to Study Loop.
Our question says, at serve, a tennis player aims to hit the ball horizontally. What minimum speed is required for the ball to clear a 0.9 meter high net about 15 meters from the serve or from the server if the ball is launched from a height of 2.5 meters? Where will the ball land if it is to clear the net, and will it be good in the sense that it lands within 7 meters of the net on the other side? How long will it be in the air? See figure 58. It kind of sets up and lays out this problem. And I also wrote down here what we were given, which is that the distance it's going to travel to get to the net, I call x, is 15 meters. Y is the height of the net, 0.9 meters. Y naught is the initial height from the server, it's 2.5 meters. And we're assuming all the velocity is in the x direction, right? So there's no initial velocity in the y direction because they launched the ball horizontally. Okay. So first we want to figure out how long it's going to take for that ball to reach the net. And in order to do this, we're going to make use of the equation that we've been using. Y is equal to y naught plus v of y, the initial velocity in the y direction, times the time, plus 1/2 acceleration in the y direction, times the time squared. Okay? Well, let's go ahead and plug in what we know for our situation here in order to find the time it's going to take for it to reach the net. Well, at the net, y is 0.9 meters, right? Okay. Y naught is 2.5 meters. We said all the velocity is in the x direction since it's launched horizontally. So v of 0y is 0. So this is going to be 0. And then minus here because the acceleration in the y direction is gravity in the negative direction. So we have the minus sign pulled out front. We'll plug in gravity, which is 9.8 meters per second squared. And then this is multiplied by t squared, but this time here is the time it takes for it to get to the net. So we'll call this t sub n for net squared. Okay, so now let's solve for the time it takes for it to get to the net, t sub n. This is going to be equal to square root, since t is squared. So we have the square root. Okay, you have 2, right, from the 1/2, and that's going to be multiplied by 0.9 minus 2.5 meters, which is minus 1.6 meters, divided by the negative 9.8 meters per second squared from gravity. Okay, so if you plug in all those values into a calculator, you find that this comes out to be 0.571 seconds. So that's how long it's going to take for it to get to the net. Okay, so then to find the velocity in the x direction that's required for it to clear the net, we can make use of the distance formula, which says that distance in the x direction is equal to the velocity in the x direction times the time it travels. We want to find velocity, right? So the required velocity in the x direction is going to be the distance to the net. We'll call that x, right? Which we call x, divided by the time it takes to get to the net, which is t sub n. So this is going to be equal to 15 divided by 0.571. And this is meters per second. You plug this into a calculator and you find that the velocity in the x direction is 26. And make the same size as the two. 26.3 meters per second. Okay. So now that we know the velocity in the x direction, let's solve the total time because we want to figure out if it does clear the net, right? if it does clear the net, how far on the other side of the net is it going to go? We want to figure out if it's going to land within the safe zone. You want to land within 7 meters on the other side of the net. Okay, so let's go back and use the original equation that we had, right? Which is, I'm going to denote here with this green star. This original equation, except this time we're going to assume that the ball goes all the way to the ground because it's reached the other side of the net. Let's get a new page here. So, okay. Now, if the ball reaches the ground, our new y is 0, right? Okay. Y naught is still 2.5 meters. So that's still the height of the server. Plus, the velocity in the y direction is still 0. Plus 1/2. And then you have gravity, which is minus 9.8 meters per second squared. And then this here is the total time the ball's traveling. Okay, so this t we're going to denote as t sub big T for total squared. Okay, so once again, solving for time to figure out how long it's in the air. You're going to have square root. Okay, 2 from the 1/2 multiplied by minus 2.5 meters, because 0 minus 2.5 is just minus 2.5, divided by the negative 9.8 meters per second squared from gravity. Okay, plug all of that into your calculator. You find that the total time the ball travels is 0.714 seconds. Okay, so now that we know the total time the ball travels, and we know that the ball is going to clear the net, we can find the total distance it travels in the x direction. We'll call this x sub t for total distance. This is going to be the velocity in the x direction times the total time the ball travels. Well, if you go back to the previous page, we found the velocity in the x direction to be 26.3 meters per second. So we'll plug that in. So this is equal to 26.3 meters per second multiplied by 0.714 seconds. Seconds cancel, and you're left with meters. Okay. And this is equal to 18.8 meters. Okay. Well, we were told the safe zone is within 8 meters of, or I'm sorry, the safe zone is within, the good zone is within 7 meters of the other side of the net. So the total distance of the good zone is within 22 meters. So if it's within 15, which is the distance to the net, if it's within 15 to 22, because 15 plus 7 is 22, if it's in that range, it's good. 18.8 meters is within that range, so we'll just write that it's good. Box it in as a solution.